All right, review sheet number 21, quick video here. Here's your definition of absolute value. A couple places you could find this definition would be in your chapter 2 notes. It would be in your chapter 2 notes. Or you could look back, I don't remember if it was last week or 2 or 3 weeks ago's review sheets, but we did the definition on there and you guys should have written it in there. Okay. Change in temperature here. A lot of you don't do it this way, but just one way that you can do it is if you actually draw a vertical number line. You'd have to draw 3 different ones, obviously, but if you just kind of put 0 on there and then say, okay, if it's going from -12 up to 25 degrees, it kind of can help you to understand, okay, what the temperature would have done to go from -12 to 0, and then what the temperature would have done to go from 0 to 25. Remember, it all has to do with absolute values, and so that's just a method you can use. Most of you don't. You pretty much just kind of think about it and you're able to get to it. But just so you know, okay. Number 2 on this step, on this right here, this box right here, I expect obviously you need to show work. That's obvious. Okay. This one here, I would only need to see 1 step because they're already in fraction form. By the way, this is chapter 3. If you get stuck at all, but we've done enough to where I think it's pretty fresh. Over here, I must see 2 steps though. I'm being very particular, but I'm telling you right here in the video that you have to have 2 steps. If you're not sure what those 2 steps are, look back to your chapter 3 notes. But you'll be able to figure that out, I think, if you just do it that way. Okay. Number 3. This is really testing your reading here, but just make sure you know that you're doing not least to greatest like we've done the last few weeks here, but make sure you're doing greatest to least. Okay, very, very important that you do it that way. Ordering them, remember you need to turn them all to fractions, all to regular numbers, or all to percentages. Okay, now remember, I've always told you that this one is always going to be the easiest one. Plus, you already have 1, 2, 3, 4 regular numbers up there already. So it looks like you just need to convert the ones that I'm going to highlight in green into regular numbers. If you have any issues with remembering how to do that, this would have come from your chapter 6 notes. Okay? All right. Number 4. This is chapter 6 also, specifically learning target number 4. We've done enough of these. I don't think I need to really talk too much. Just remember the whole strip represents 100%. And then you're going to identify that percentage and then cut it however you feel you need to. And then this up here is going to represent either a part or a whole. Okay? And then from there, I think you guys can figure it out. I'm not going to give you any more because we just did it and we've done so many now. The one thing I am going to tell you though is to be real careful because the directions are very clear and I will not give you credit if you forget about this. Okay, so I'm telling you on the video once again just to make sure you're all good. But yeah, that I want to see the percent proportion. If you have any issues with this problem, you can go back and check out the video or your notes from this learning target. Okay, so any one of those is going to be good, or a worksheet, or even a past test, however you want to look at. But we just did it; it's fresh. I don't think we have any issues there. So let's go on. Proportional. This was actually, I'm not sure I don't know if this definition has been in our notes at all, but I know that for sure we've done it the last couple weeks on review sheets. So I would take a look at your review sheet number 20 or 19. One of those two, we had this exact question. As far as figuring out whether the two are proportional, okay, you should know what I called the big 3 methods and the little fourth. You need to do one of those in order to show your work. So I would need to see work because it says prove it. Okay? By the way, I should have wrote W here for work on that one. Turning them to regular numbers. Obviously, this one needs work. Okay? All right. This one here, writing an algebraic expression. This is learning target number 1 from the current chapter we're on, chapter 7. So if you have any questions about how to do that, take a look back at that. Just you got to know what these words mean, words like that. But that's all in your notes, so I'm not going to help you anymore with that. We've done them the last few review sheets here. I think you guys should be kind of on, kind of past this a little bit. All right? Okay. Division, this is going to be chapter 3. You need to remember that the first number right here, that's always going to be your dividend. That's always going to be your divisor. You're going to have to show me your long division. Okay. Now I'm just going to make it I'm not going to tell you anymore, but I'm just going to say that divisor right there, there's something special that needs to happen in order to do long division. There's a little step that has to happen with that divisor, okay, in order to be able to do it. And then you should remember how to do it from there. But go back to your chapter 3. I don't remember the exact learning target. I want to say learning target maybe number 8 or 9 or 7, somewhere in the higher ones, okay? All right, here, adding and subtracting mixed numbers. Now, the way I've always taught this is I've always taught my students, because this is 5th grade. This is 5th grade review. Okay? Now you can get on YouTube or anything and you could type in adding and subtracting mixed numbers and you'll remember. Now we haven't done a lot of mixed numbers. So what I like to do is I like to just convert them. Just like we do with division problems or multiplication problems. I like to just convert them. Go around the barn. So 3 times 4 is 12 plus 2 is 14 over 3 plus 8 times 7 is 56 plus 1 is 57 over 8. And then just remember, you must have a common denominator. And then remember, whatever you did to the bottom, you must do that same thing then to the top. Okay? So that's how, I mean, you don't technically have to convert these to impropers, but I think it makes it a little easier, to be honest. But you guys do it how you want. So you'll have to find either a QCD or the LCD. And I will tell you that in this situation in particular, the QCD and the LCD are actually the same exact thing. Okay? QCD is when the quick common denominator, that's when you just multiply 3 and 8 to get a common denominator. The LCD would be LCM of the denominator. So you'd be doing the trees for 3 and 8 and then finding the LCM. That would be the same thing here. Okay? And then this one, you're going to have to do the same process involved. The only difference being that now it's subtraction. So there's really no difference. And then what's cool is once you've done all the work finding all the common denominators here and everything and changing the numerators, these are the same. They're just different order. So now we're subtracting this from this. You guys see how that works? So you don't have to it's not like we're making you do another QCD or LCD. You can use the same exact, whatever you got as your new fractions, use those again here and then subtract. Okay? All right. This one here, number 9. Okay, now I would advise you to please, obviously need work. This would be chapter 7, learning target number 2. I would advise you all to find on page 2, like right here is where I did mine. Right here, there was all kinds of room right here. So I did mine like up here to the right. I think it was in the upper part of the page. So I would just rewrite it and do it up there somewhere because it's going to be multiple steps. Now, something might look kind of weird. These things right here might look a little weird. Now, you've probably seen me do these all years and when we were like outlining the fake ratio or whatever. But those are just fancy parentheses. They don't have to use those. They could have just put parentheses in here like that. But why we did that was just to make sure you know that they're the same thing. You do them in the same step. So when you go inside brackets or parentheses, you have to remember to have a little mini PEMDAS, right? So that's just for the bracketed area. That's where that PEMDAS goes. Okay? Again, you know I need to see one step at a time, so you should only be adding, subtracting, multiplying, or dividing one of those each time before you rewrite the entire thing. Okay? This right here is chapter number 4. I don't remember the specific learning target. I want to say learning target 2. That seems like I remember that, but it's right in there somewhere. It's making ratio tables. The key word here is scaling. Go back to those notes right there if you have any issues with what scaling is, to remind you what scaling is. Okay? Let's go to the next page. Okay? This is just a proportion question here. We have there's those brackets we talked about. 2 cups to make 6 cookies, and then it wants to know, well, then how many cups would I need to make 10 cookies? So you just got to figure out which one of these proportions would give you the right one. So they didn't put any labels on theirs, which I hate. That's why I always make you put labels. So I'll let you go from there, but think about it. This is your fake ratio. This is your real information right there. We're trying to figure that out. So that would be a variable. Okay. Down here, I'm not going to talk too much about this one. You should know something about all fractions. I'm just going to leave it at that. Next page. Okay, now this is called a percent bar, or a percent diagram or whatever. This is very similar to the strip diagram that we always have done, like we did on the front and what we did on learning target number 4 on the previous chapter we just did. So what I'm just going to show you real quick, I'm not going to do it for you because this question is actually relatively easy, I think, for you guys. You're able to kind of see it. But really, here's the difference. We would have, since it gives us 20%, we would have taken this and we would have cut it like this. So we would have said 20%, 20%, 20%, 20%, 20%. I should have percent signs on there, but I just want to save time. Okay. And then basically we would have said, okay, the whole strip represents 100, and then the whole strip represents some sort of total. Okay, if my thing would go over there. That would represent some sort of total like that. Okay. Now, what the big difference here is they actually count up. So they count 20 and then 40, then 60, 80, 100. We actually break it into 20, 20, 20. But regardless, this right here is still 20% to there, right? If I drew a line right here and said, what's everything to the left of there? That's 40%, just like they have it right there. Okay? You know, so it's the same principle. It's just labeled a little bit different. And then they put, instead of having their numbers on the inside of the strip, they put them on the top. So what it's saying is if you have $0, that's 0% of our total. But if you have $6, that would be 20%. Well, if that means there are $6 in the first section, then that means there's 6 more. That would mean there'd be 12 there because 40% would be 12. So I'll let you go from there. If you want to check with a proportion once you get done, that would make me happy because that's always a great way to just ensure that you're getting it correct. Okay? This one, I'm going to let you do this one kind of on your own. This is kind of a, basically a reading question, more or less. This question is really, quite frankly, less about math, more about reading than anything. So I'm going to let you go on this one. You're just going to have to make a comparison, or a conclusion, I guess, about the elevation of the city compared to the temperature. So you're going to make a general statement about what's happening as the elevation goes up or it goes down, and what happens to the temperature. Okay? All right. This is a dot plot, okay, or a box plot, or no, not a box plot. Sorry, dot plot. Okay. Sometimes you've seen these with dots. Just remember, every X is representing a student. Okay. It's just saying, like this student right there, even though it's on 0, that's just saying that there was one student in the class that didn't volunteer any time. That student only volunteered, or that one student volunteered 0 hours. Then there were 2 students that volunteered 1 hour, and so on and so forth. Okay, the one thing that you should always do when you're given one of these dot plots is you should always make a list. Think about this. If she was really tallying this up, she would say, okay, how many of you spent 0 hours volunteering? One person would raise their hand, so we'd have 1 0. How many of you spent 1 hour? 2 people raised their hand, so we'd have 2 1s. How many people spent 2 hours? 3 people raised their hands. Okay, and then you should go through there and do that. So you should always do this when you're given one of these, because it just kind of makes you understand what you're seeing. And I'm going to stop there. So I ended right there. You can finish the rest of these to the right over here. I did not do them. And then finish out your list. Okay? So you should be able to figure out how many students are in the class based on what I just told you. What is the mean number of hours? Okay, now remember, mean is an average. Okay, that is when you take the total, add it together, the sum, and then you divide by however many there are. So sum divided by amount. Okay. Mode, another word for that would be the most, or most often occurring. The range, remember. Well, I'm not going to tell you what range is because we've done it 100 times this year. So you should know what range is. And then finally the median, that's the middle number. So you'll have to figure out what's in the very middle. Okay. Here, this is a little thermometer. It's showing the temperature. Right here is 0 degrees. So as you can see, the temperature is definitely below 0. you're going to have to figure out what that mark right there is. That's what we need to figure out. Okay? So you're going to have to think about how this thing goes from 0 to 10 degrees and what it's counting by. Figure out the interval, and then that'll be able to tell you what the temperature is at that time. But this, guys, all this is a vertical number line. Okay? This is all that is. It's just in thermometer form, but it's the same thing. You have 0, you have -10, you have 10, like that. You just have to figure out what the temperature is right there. Okay? All right, guys. Hope this helped.